Welcome to chapter 5. We're going to skip around a little bit here. I know we just did chapter 3, which was systems of equations. Now we're jumping into chapter 5, which is quadratic functions. So quadratic functions, quite simply, are any function that has a term that has an exponent of 2. And also not some. That would be next chapter. So in this lesson, we're just going to talk about identifying quadratic functions and their graphs, and then different parts of it. So I'm not going to get into a whole lot in this lesson. It's kind of setting up for where we're going to go later in the chapter. But yeah, we're going to talk about later in the chapter. We're going to solve functions. We're going to factor them. We're going to graph them. So all that stuff. As we get in. But again, today's is more about just kind of a couple building blocks to get us to where we're eventually going to go. The standard form of a quadratic function is this, where it's f of x is equal to ax squared plus bx plus c, where a, b, and c are going to be numbers. A specifically can't be 0, because if a was 0, then there would be no quadratic term, and then it would stop being quadratic. Let's see here. Hold on. So quite simply, this is the quadratic function. That would be the linear function, and that would be the constant. So the first example here says determine whether each function is linear or quadratic. Identify the quadratic, linear, and constant terms. You can only identify if a function is linear or quadratic if it's in standard form. So right now it looks like it's linear, right? Because you've got some linear terms. But if you actually multiply these together, standard form would not be leaving it like this. It would be breaking it apart and putting it in order. So x times 3x is 3x squared. X times -1 is negative x. Negative 5 times 3x is negative 15x. Negative 5 times -1 is plus 5. You would also combine like terms. So this function is going to end up looking like f of x is equal to 3x squared minus 16x when you combine these two, plus 5. So that is a quadratic function because it has a quadratic term. It also asks us to identify each of the terms. So this would be the quadratic, this would be the linear, and this would be the constant. We're going to do the same thing with part B. This looks like it's quadratic, right, given that it's got some quadratic terms, but if you actually combine the like terms, that and that add to 0. So you're left with f of x is equal to 5x. So this is a linear function, right, because there is no quadratic term, and the only term there is linear. So that would be for identifying that. 2x minus 1 squared looks linear because you've got the 2x in there. But remember, if you are squaring a binomial, what that really means is 2x minus 1 times 2x minus 1. But to get this in standard form, you would FOIL this together. 2x times 2x is 4x squared. 2x times -1 is negative 2x. Negative 1 times 2x is negative 2x. Negative 1 times -1 is positive 1. Again, combine like terms. So the two middle would combine to negative 4x. And you have f of x is equal to 4x squared minus 4x plus 1. So this would be a quadratic function. First term there is quadratic. The second term is the linear. The third term is the constant. Couple things to identify in terms of vocabulary. A parabola is the graph of a quadratic function. So you can see that it's actually y equals x squared, basic one. It's basically, it's described as a U shape. Okay. The axis of symmetry is a vertical line that divides a parabola into two parts that are mirror images. So a axis of symmetry for this would be a vertical line that would cut that in half. The vertex of a parabola is a point at which a parabola intersects the axis of symmetry. So in this case, it is this point here that I'm highlighting. The y value of the vertex of a parabola represents the maximum or minimum value of the function. We'll get into that later in the chapter, but essentially anytime you're given a word problem that's talking about finding the maximum or minimum of something, you're going to find the vertex, specifically the y-coordinate of that vertex. Each point of a parabola has a corresponding point on its mirror image. Both points are equidistant from the axis of symmetry. So for instance, this point highlighted here, sorry, I mean make an E, that point there has a mirror image on this side. They are equidistant, meaning it's the same distance to the axis of symmetry, which is 1 unit in this case. All right, below is the graph of the function y equals x squared minus 6x plus 11. All right, you're going to identify the vertex and the axis of symmetry, identify points corresponding to P and Q. So the first thing is the vertex. The vertex is basically the bottom, right? In this case, it's the bottom. If it was opening the other way, it would be the top. The ordered pair there appears to be, if that's halfway between 2 and 4, is 3. So the vertex appears to be here at 3, 2. The axis of symmetry is a vertical line that goes through the vertex. So the axis of symmetry is a line. It's a vertical line. It's always a vertical line. So it's always going to be x equals. And if you already know the vertex is going to be x equals whatever the x coordinate of the vertex is. So in this case, it is 3. Identify points corresponding to P and Q. So the notation for that, for P, the point corresponding to P is not talking about the point that's identified as P on here. It's talking about the other one. So corresponding would be on the other side. You use a little dash there to indicate it's the point on the other side. So the ordered pair there appears to be 5, 6. The point corresponding to Q is the point right there. So it would be 2, 3. All right, so that's it. I will have a, well, there's an exit ticket already available for you to do. So again, do the exit ticket to earn your classwork points for that. We'll go over the exit ticket in class tomorrow. You can start the practice certainly ahead of time if you'd like. Otherwise, class time on Tuesday, tomorrow, will be designated for completing the practice. Let me know if you have any other questions. And again, complete the exit ticket. We'll go over the exit ticket Tuesday first thing in class, and then you'll have time to work on the practice. All right, so again, let me know if you have questions and get to it.